Chronic stress physically shrinks your hippocampus by up to 15%. On actual MRI scans, with a measurable timeline, documented by the National Institutes of Health. And while that's happening, two other brain regions are being remodeled at the same time. One of them is shrinking, same as the hippocampus. The other one, and nobody talks about this part, is growing. Getting bigger, getting stronger, getting more reactive, more in control of how you behave, what you feel, and how you respond to basically everything in your life. That region growing, that is the problem. And it is why chronic stress feels like it gets harder to manage the longer it goes on, not easier. You're not imagining that. Your brain is structurally changing to make sure of it. In the next few minutes, the exact mechanism of how your brain handles stress, what's physically happening to three specific regions right now if you're under sustained pressure, and starting with the finding most people have never heard, what the 2025 and 2026 research says actually reverses it. Let's go. Your brain calls in the military before you even know there's a threat. Before we get to the damage, you need to understand the machinery. Because the damage only makes sense once you see how the system is built, and why it was never designed for the kind of life most of us are actually living. When your brain detects a potential threat, a looming deadline, a difficult conversation, a noise at 2 a.m., or an email from your boss that just says, "Can we talk?" With zero additional context, that 6-word message has probably caused more cortisol spikes in modern humans than every lion that ever lived combined. That email understood the assignment. Unfortunately, the assignment was to destroy your nervous system. Anyway, the threat signal enters your sensory thalamus. And here is where it gets interesting. Neuroscientist Joseph Ledoux at New York University spent decades mapping what happens at that junction. His research identified what he called the low road, a direct subcortical pathway from the thalamus straight to the amygdala, completely bypassing the cortex. What that means practically, your amygdala receives the threat signal and starts responding before the information has even reached your prefrontal cortex, the part of your brain responsible for rational assessment, context, and the question, okay, but is this actually something I need to lose my mind over? The amygdala does not wait for that answer. It is already called in the military. Within milliseconds, the hypothalamus fires, the sympathetic nervous system engages, adrenaline floods the bloodstream, heart rate spikes, breathing shallows, blood flow redirects away from digestion and toward your muscles, pupils dilate, your entire physiology shifts into fight or flight. Your body literally started prepping you to run before your brain finished reading the subject line. Then, 12 to 15 minutes later, the second wave arrives. The HPA axis, the hypothalamic pituitary adrenal axis, releases cortisol from the adrenal glands. If adrenaline is the emergency alarm, cortisol is the sustained high alert mode that moves in afterward and refuses to leave. And here is the core mismatch that explains everything. This system was engineered for acute, short-duration threats with a clear physical resolution. Predator shows up. You run or you fight. Predator is gone. Cortisol drops. System resets. It was not engineered for a rent that's 2 weeks overdue, a job that follows you home on your phone, a relationship that needs more work than your current bandwidth can handle, and a news cycle that treats every single headline like it is personally, specifically coming for you, all of it running simultaneously indefinitely, with no finish line and no physical way to discharge the stress response. When you run this system without a reset, your brain starts physically restructuring itself to handle the load. That restructuring is not going in your favor, and it happens faster than most people are told. Hit subscribe if this is the kind of breakdown you want more of. This is what we do here. 3 brain regions. 3 completely different fates. Quick note before we go in. Acute stress, the contained, short-duration kind, is not inherently harmful. In controlled doses it sharpens focus, improves reaction time, and can actually enhance certain kinds of memory. The stress response is adaptive. It evolved because it works. Chronic stress is a different situation entirely. And the difference is not just subjective, it shows up structurally, on brain scans, in regions you are using to navigate every decision you make. 3 regions. Let's go. Region 1, the hippocampus. The hippocampus is your brain's primary hub for learning and long-term memory consolidation. It is also one of the only regions in the adult brain that keeps generating brand new neurons throughout your entire lifetime, a process called adult neurogenesis. Your brain is literally growing new cells in here on an ongoing basis, which is genuinely one of the more impressive things about being human, and we should appreciate it more. Cortisol, at chronically elevated levels, is directly toxic to that process. Data compiled by the National Institutes of Health shows that chronically stressed individuals have measurable hippocampal volume reduction of 10 to 15% on MRI, directly correlated with sustained cortisol elevation. Research from Harvard Medical School found that cortisol exposure over as little as 3 weeks can reduce dendritic spine density, the physical connections between neurons, by approximately 20%. A 2024 study in Research in Pharmaceutical Sciences confirmed that chronic stress significantly suppresses neurogenesis in the hippocampus, and that this suppression maps directly onto impaired memory performance and degraded spatial reasoning. Real-world consequence: if you are chronically stressed, your ability to form new memories, retain new information, and work through cognitively complex tasks is not just harder in a subjective "I feel foggy" sense. It is structurally, anatomically compromised. Brain fog is not a vibe. It is a measurable event. Now, the hippocampus is actually the good news part of this story, because it is the region most responsive to recovery interventions. What chronic stress does to the prefrontal cortex is faster, more immediate, and has more direct consequences for the decisions you are making every single day. Region 2, the prefrontal cortex. The prefrontal cortex is your executive brain. Planning, decision-making, impulse control, and most critically, the regulation of emotional responses coming out of your amygdala. It's the part of your brain that, theoretically, is supposed to show up after the alarm fires and say, "All right, let's think about this rationally." Under chronic stress, it increasingly can't do that job. Research led by Dr. Amy Arntzen at Yale, published in Neuroscience and Biobehavioral Reviews, established the core mechanism. High levels of noradrenaline and cortisol impair prefrontal function by engaging low-affinity adrenoceptors that actively reduce the firing rate of PFC neurons, not just making it harder to think, biochemically turning down the volume on the neurons responsible for thinking, which, if you've ever tried to have a rational conversation with someone mid-freakout, or been that person, now you have the neuroscience to explain exactly what was happening. The 2025 study from Trier University's Institute for Cognitive and Affective Neuroscience confirmed this in real time using functional near-infrared spectroscopy, measuring prefrontal blood flow during cognitive tasks after a stress induction. Finding: working memory is most severely impaired in the first 10 minutes after a stressor, and again at the 25-minute mark, precisely when cortisol is peaking in the bloodstream. Here is something you can use immediately. The 25 minutes following a significant stressor, you are making decisions with a partially offline prefrontal cortex. That difficult email you want to fire back at. That financial call. That conversation that actually matters. You're doing all of that with degraded executive function. Wait 30 minutes. Minimum. That is not procrastination. That is neuroscience, and it costs you nothing except the satisfaction of responding in the heat of the moment, which honestly is a cost worth paying. Chronic exposure to this cycle over time produces dendritic atrophy in the prefrontal cortex, a literal physical reduction in the neural architecture that makes rational thought and emotional regulation possible. But here is the region nobody in the stress content space actually leads with. And honestly, it should be the headline. Region 3, the amygdala, the one that's getting stronger. While chronic stress is shrinking the hippocampus and degrading the prefrontal cortex, it is doing the exact opposite to the amygdala. Research synthesized from Yale, UCL, and multiple longitudinal fMRI studies has consistently shown that chronic cortisol exposure produces dendritic extension in the amygdala. It physically grows more reactive. The threat detection system that was already overactive gets structurally reinforced. Data in the cortisol literature places the increase in amygdala reactivity under chronic stress conditions at up to 30%. So here is the loop mapped clearly. The more chronically stressed you are, the more reactive your amygdala becomes. A more reactive amygdala generates stronger, faster stress responses. Those stronger responses dump more cortisol. More cortisol further degrades the prefrontal cortex. A weaker prefrontal cortex is less capable of dampening the amygdala, which makes you more reactive, which generates more cortisol. The loop does not self-correct. It compounds. And this is why chronic stress is not a willpower problem. It is not a discipline problem. It is not a you just need to find the right morning routine problem. Though if your morning routine involves 47 open tabs and no music, that is its own issue. It is a structural biology problem. Your brain has been physically rewired to be more sensitive to threat and less capable of regulating its own response to it. That's what's happening. Now let's talk about what actually changes it. What the research actually says reverses it. So the loop compounds, the amygdala grows, the prefrontal cortex weakens, and it happens on a faster timeline than anyone previously thought. The question is whether any of it is reversible. The answer is yes. With caveats the data is very specific about. 3 findings, starting with the one that's newest, least covered in mainstream wellness content, and most likely to actually change something about your day. Finding 1. When you exercise after stress matters as much as whether you exercise. A 2026 study examining hypothalamic CRH neurons, published in BioArxiv, identified what the researchers called a critical therapeutic window that opens immediately after a stressor. During this window, exercise has an outsized neurological effect that it does not produce at neutral times. Specifically, exercise performed in this post-stress window increases both circulating cortisol and hypothalamic BDNF, brain-derived neurotrophic factor, simultaneously. And that synergistic action in the stress response neurons was shown to reverse the synaptic changes, the metaplasticity, that the stressor itself had induced. The researchers described it as a period during which the brain is actively primed to benefit from physical movement. Plain language version. Going for a run or hitting the gym 30 minutes after a genuinely stressful event may be doing something neurologically different and more reparative than the exact same workout on a calm, neutral morning. The stress opens a biological window. Exercise can exploit it. This is a preprint finding and needs replication before it becomes clinical guidance. But the mechanism is plausible, consistent with existing BDNF research, and worth taking seriously. And honestly, if you were going to procrastinate on working out anyway, now you have a neuroscience-backed reason to at least time it correctly. Finding 2. BDNF is the recovery mechanism, and you can raise it. BDNF, brain-derived neurotrophic factor, is the primary protein driving hippocampal neuroplasticity. It promotes the growth of new neurons, strengthens synaptic connections, and directly counteracts cortisol's neurotoxic effects on the hippocampus. Think of cortisol as the thing suppressing your brain's natural repair hormone. Sustainably reducing chronic cortisol lets that repair hormone do its job again. A 2024 study in eLife Sciences followed 332 healthy adults through 9 months of structured mental training, sequenced mindfulness, socio-affective, and socio-cognitive modules. Result: training significantly increased serum BDNF. This increase was mediated by measurable reductions in cortisol output, and hippocampal volume measurably increased in the training group relative to controls. 9 months. Structured. Consistent. That is the honest timeline the data supports. Functional improvements, how your brain actually behaves, emerge faster than structural ones. But the structural recovery is real, documented, and visible on the same MRI equipment that showed the original damage. Finding 3. Mindfulness specifically rebuilds the connection stress is destroying. A 2024 systematic review in Biomedicines, synthesizing neuroimaging research, found consistent evidence that mindfulness and meditation practice reduces amygdala reactivity and strengthens functional connectivity between the amygdala and the prefrontal cortex. That is the exact connection chronic stress degrades. Mindfulness appears to rebuild, or at minimum significantly reinforce, precisely the neural pathway that sustained cortisol is taking apart. Honest caveat: a large randomized controlled trial in Science Advances found that 2 months of mindfulness practice in novices produced no measurable structural brain changes. Functional effects, actual behavioral change, emerge earlier than structural ones. The effect is real. The timeline is longer than every wellness app's onboarding screen will tell you. What the research actually supports: reversal is real, requires months of consistent intervention rather than weeks of effort followed by 3 weeks of nothing, and works best when your cortisol is genuinely and sustainably reduced, not managed during a 20-minute session while your life remains structurally unchanged. Subscribe for the follow-up on habit formation, the neuroscience of why your brain resists the behavioral changes you're trying to make connects directly to everything we just covered. That one's next. Before I wrap, remember this. Changes from chronic stress can begin showing up on MRI scans in under 30 days. Not years. 30 days. The amygdala reacts before you're aware of a threat. Cortisol rises before you can think it through. And the prefrontal cortex can weaken before you even notice it happening. That's not a character flaw. It's your brain running a survival system in a world it was never designed for. Understanding that won't make you immune to stress. But it gives you something just as valuable, better choices. And sometimes, clarity is where recovery begins. Subscribe for more neuroscience, and drop a comment below. I read everyone.